We're about to dive into a really wild idea. What if the reality we see, everything around us, space, time, isn't what we think it is? What if it's all built on a kind of hidden geometry?
I mean, really think about it. What if the smooth, solid world we experience isn't the base layer of reality? What if it's actually an illusion, something that emerges from a deeper, geometric code?
Here's an analogy. You know when you're watching a super high-res movie, it looks completely real, totally seamless. But you know that if you get close enough, it's all just pixels. Well, this theory suggests our universe might be just like that, a beautiful, convincing projection on a kind of cosmic screen.
So let's peek behind that screen. Instead of a smooth, continuous fabric, this idea proposes that space-time is actually a grid, a lattice made of tiny fundamental units, almost like a crystal.
Okay, so if reality is made of pixels, what are they? What do they look like? Let's zoom in. And I mean way in, past the galaxies, past the atoms, past everything we know, down to the absolute bedrock of space and time itself. And this is it. According to a framework called the macroscopic mass unit theory, or MMU, this shape, a dual tetrahedron, is the fundamental pixel of our reality. They call it the cell, kind of like the original cell that everything else is built from.
But just knowing the shape of the pixel isn't the whole story. Not even close. The real secret, the engine that drives basically all of physics, is what's happening inside this tiny geometric shape. You see, this cell isn't just a static block. It's alive. It's dynamic. Think of it like a tiny machine that can move in 3 hidden, internal ways. And these aren't movements through space as we know it. These motions are happening inside the geometry of the cell itself.
So the first mode of movement, called W2, is the electric mode. The easiest way to picture it is as a stretch. It's an internal pulse that, as we're going to see, gives rise to what we experience as electric force. The second mode is W3, the torsional mode. This is an internal twist, a rotation happening right inside the cell's geometry. Now keep this twisting motion in your head because it might just be the key to one of the biggest mysteries in all of quantum mechanics.
And boom, here's the connection. This internal twist can happen in 2 directions, right? Clockwise or counterclockwise, and that is proposed to be the actual geometric origin of quantum spin. It could finally explain why particles have this weird property of spin up or spin down. It's literally the geometry of spacetime twisting one way or the other. And finally, there's W4, the volumetric mode. You can think of this one as a squeeze or a breath. It's the entire cell expanding and contracting, changing its own volume. And this rhythmic breathing of spacetime's pixels, that's what we experience as gravity.
Okay, hold on. If every single point in the universe is secretly stretching, twisting, and squeezing all the time, why on earth does reality seem so normal, so stable? Why don't we feel any of that? This question leads us to the most profound idea in this whole theory.
And it all comes down to something called the projection principle. The best way to think about it is with a shadow analogy. Imagine you're a 2-dimensional creature living on a wall, and all you can ever see are the shadows cast by a complex 3D world that you can't even imagine. So this is the absolute key. We never ever get to see the individual stretch, or the twist, or the squeeze directly. Just like the shadow creature on the wall, we only see their combined effect, their shadow, projected onto our reality. All that incredibly complex internal motion gets flattened down into the one dimension we can actually observe.
And get this, even applies to time. In this model, time isn't some fundamental thing that just flows. It's an emergent property. Our experience of time, what our clocks measure, is like a recipe. It's a very specific mix of the stretch, the twist, and the squeeze, all projected together. Our sense of now is just one particular shadow of a much deeper, hidden reality.
So, why would we even entertain such a strange idea? What's the point? Well, the payoff is potentially huge. If this whole projection idea is right, it means we can start to see the fundamental forces of nature not as separate things, but as different shadows cast by the very same object.
And that's exactly what this picture suggests. All of a sudden, things start to click into place. Quantum states? Those are just stable, repeating patterns of the hidden motions. Spin? That's the W3 twist. Gravity? It's the W4 squeeze. The electric force? It's the W2 stretch. They aren't different forces at all. They're just different angles of the same underlying geometric dance.
I mean, it's a beautiful, elegant picture, right? But is it just a cool story, or is it actual science? How in the world could we ever test an idea that says the true reality is fundamentally hidden from us?
Well, the idea is that we have to look for the seams in the illusion. You know, glitches in the matrix. If our reality really is a projection, maybe it's not a perfect projection. Maybe we can find tiny, subtle inconsistencies where some of that hidden motion bleeds through into our world.
And we would look for these little echoes in our most precise experiments ever. For example, if time is just a projection, maybe, just maybe, it doesn't flow at the exact same rate for every type of atom. Our best atomic clocks might just be sensitive enough to spot that difference. Or we could look for tiny, unexpected shifts in the light coming from different atoms, little clues that betray the geometric grid underneath it all.
So, is our universe the real deal, or is it just a shadow play? Is this rich, complex reality we live in just a projection of a simple, hidden geometry? We honestly don't know the answer yet. But the first clues might already be out there, quietly ticking away, deep inside the heart of our most precise instruments.